Take your textbooks out if you would. Please open to page 109. We have been practicing with signed numbers a lot. We talked about adding signed numbers a couple days ago. And in class, we have two basic rules for adding signed numbers. If the signs are the same, class, we're going to add, and then we're just going to keep whatever sign we're adding, because it's the same anyway. But if the signs are different, class, we need to remember to subtract. And then how do we know which sign to keep? Whichever number is bigger, but really we're talking about absolute value, right? So technically, yes, I know a positive 1 is bigger than a negative 9. But the negative 9 looks bigger, the negative wins. We keep the negative sign. And then yesterday we talked about subtracting signed numbers. I said, we don't really do that here. We never really subtract, class. We add the inverse. Good. Subtraction is adding the inverse. That's what we're going to do here. So if we see a subtraction problem, we're like, nah. We change it to addition, and we change the sign after the subtraction. We add the inverse. And we were practicing with that in the homework. Numbers 22 to 37 on page 109. Number 22, what did you get for your answer, Danielle? Ooh, those are not inverses. They're not going to cancel. If I took $3 from you, I was like, oh, I'm sorry, Danielle. Here, let me take 3 more. Are we even now? No, if I took $3 and I took $3 more, what has happened? Besides me being a thief. Specifically, I have taken $6 from you, and that's negative from your perspective, right? Negative 6 should have been our answer here. Add and keep the sign. Number 23, Michael. Positive 6. Number 24, Hayden. There's your inverses. If I came and was like, you know what, Hayden, you're my favorite. Here's $5. And we'd be like, oh, that's just wrong. And then I was like, give me those $5 back. Okay, now besides you being very confused, nothing's actually changed between us, right? Your financial state, my financial state is the same as it was. It cancels out. 0 our answer. Number 25, Aubrey. 0 again. Same thing. We have inverses. A negative 4, a positive 4, they just cancel out. Number 26, we can't do that. What are we going to do here first, Lexi?
Add the opposites.
Add the inverse specifically to change this to negative 1 plus negative 2. And now the signs are the same. We add and keep the sign. We get negative 3. Number 27, Glenn. Again, it says subtract. We don't do that here. We're going to change it to say negative 4 plus positive 3. Now the signs are different. We get negative 1 when we subtract, keep the sign of the greater absolute value. Number 28, Evie. It says subtract. No, no, no. We're going to change it to 5 plus negative 1 to get 4. Number 29, it says subtract. No, no, no. What are we going to do here instead, Danielle? Negative 6 plus positive 11 gives us negative 6 plus positive 11. Signs are different. We don't add. When the signs are different, we have to subtract to get a 5. And then which sign, negative or positive? Positive's the winner, so we're going to keep that. Again, it's as if I took $6 from you, but I'm like, oh, I shouldn't have done that. Here's $11, Danielle. I mean, I'd do that all day if I were you, right? Make $5 out of that, you know? Steal from me anytime if you're going to pay back more because you feel bad, you know? Like the Bible talked about, you know, if you steal from somebody, you have to pay back 4-fold or something. That was in the Old Testament law. Like, hey, steal my sheep if you want to get 4 back from it. Anyway, but money's better. Anyway, so positive 5 should have been our answer. Number 30, it's not a subtraction. That's a negative sign. It's a positive 4 and a negative 1. We just get what, Michael? Positive 3. Though if you viewed it as a subtraction sign, it works out the same anyway. But I want you to get in the habit of seeing it as a negative, not as a minus. So 3 our answer. Number 31, Hayden. Negative 6. Signs are the same. Add and keep the sign, get you negative 6. Number 32, Aubrey. Negative 4. Add and keep the sign. Number 33, Lexi.
1.
Positive 1. Subtract, keep the sign of the greater absolute value. Then on number 34, we have multiple add-ends here. And what I told you to do, Glenn, was to start by getting together all your negatives and then get all your positives. Well, when you get all the negatives, I've got a negative 1, a negative 6, a negative 7 gives me negative 14. And I've got one random, lonely little positive 3. Now, I've done all my addition. Normally, I would have done more addition, but I didn't need to. Now I do only one subtraction to get. Keep the sign of the greater. Negative 11. Negative 11 should have been our answer. Same thing happens on number 35, Evie. We add all our negatives together. Negative 6. And add all my positives together. positive 10, and now I do one subtraction to get positive 4. On number 36, I get all my negatives together, Hayden.
There's 12. No.
I get all my negatives together, there's 2 of them.
40.
Negative 40. And I get all my positives together.
34.
What'd you say?
34.
Positive 34. And then I do one subtraction to get,
Negative 13.
ooh, 40 minus 34?
Negative 6.
Negative 6. There we go. 6. Then, of course, we'll keep the negative. And then on the last one, number 37, we get all our negatives together. Michael?
Good question.
You didn't show that step?
I did.
Can't find that step. Danielle, we get all our negatives together to get? Anybody?
45.
Negative 45. There we go. She got it. All right, and then get all my positives together, class. Positive 35. And I do one subtraction to get anyone?
Negative 10.
Negative 10 for my answer. Questions on adding, subtracting signed numbers. Yes, sir?
It's not a question, but I found my work.
Oh, found it. Okay, good, good. Just a little late, but okay, better late than never, I guess. All right, any questions on adding, subtracting signed numbers? How many feel like I've got this signed number thing really well? Like you could give me a quiz right now, I'd be awesome. How many I would really love it if the quiz were not today because more review would probably be helpful. All right, the quiz isn't today. All right, next thing in your notes though, we want to talk about multiplication of signed numbers. We talked about adding, talked about subtracting. Those subtractions really just adding the inverse, so we was really talking about adding yesterday as well. I want to talk about multiplying signed numbers, and I want to take you back for just a moment to your first grade days, when your teacher wrote this problem on the board. 4 plus 4 plus 4. And the teacher would say something like, but class, there's a faster way. I want to teach you a shortcut. I could write this as 4 times 3. And that means I've got 3 4s being added. And 4 times 3, we're going to memorize is 12. After all, 4 plus 4 plus 4 class is 12. Right? Well, let me show it another way. Positive 4 plus positive 4 plus positive 4 equals positive 12. Positive 4 times positive 3 equals positive 12. Right? Because all those numbers your teacher was using were positives. You didn't know about negatives back then. What if you had? What if you had a negative 4 plus a negative 4 plus a negative 4? What would that be, class? That would be negative 12, right? Because negative 4 times 3 or times positive 3 equals negative 12, right? Correct? Yeah. Now, what if, though, we'd had a negative 4 and we subtracted it from nothing, and we subtracted another negative 4, and we subtracted another negative 4? Well, we never really subtract in algebra class. We would add the inverse, right? So we'd have to add the inverse, and all of a sudden this would look just like this problem, wouldn't it? So this would be this would be a positive 12. But you notice I subtracted 3 times. That's the same as multiplying by a negative 3. After all, if adding 3 times is a positive 3, subtracting 3 times would be multiplying by a negative 3. But it was negative 4s being multiplied. So negative 4 times negative 3 gives positive 12. What if I subtracted a positive 4 and subtracted a positive 4 and subtracted a positive 4? We don't subtract in algebra class. We add the inverse. So I make this adding the inverse, adding the inverse, adding the inverse. And that would give me what? It's the same as what we had a minute ago. It's negative 12. Well, that would be the same as taking a positive 4 like we started with, and since I subtracted it, it would be like multiplying by a negative 3, which gives me negative 12. Now, here's where I'm going with all of this. So if I lost you, it's okay. You don't need to understand any of that if I've totally lost you. If you did, you're just ahead of the curve. Here's what we need to notice. Negative times negative gives positive. Positive times positive gives positive. Positive times negative gives negative. Negative times positive gives negative. Here's the rules. If the signs match, if the signs are the same, you're going to get a positive. If the signs differ, end up with a negative. And write that off to the side there. In fact, you might see that already there Yeah, you see that this the second bold line on page 109 says when multiplying two factors with opposite signs, the product is negative. Just underline opposite signs and negative, because we're too lazy to underline all of it. Just underline opposite signs, negative. Then go down to the bottom where it says same sign, positive. Same sign, positive. Now again, these are multiplication rules. Let me tell you where students struggle in 8th grade. There, if the signs are the same, you keep the sign. Here, if the signs are the same, it's automatically a positive. There, if the signs are different, you have to pick the sign of the bigger. Here, if the signs are different, it's automatically a negative. Addition sign rules are different than multiplication sign rules, so you have to keep straight what you're doing. Does that make sense? -4 plus -3 class gives -7, add and keep the sign. -4 times -3 class gives +12, because you automatically get a positive if the signs match. We've got to be able to keep those two processes straight and keep those sign rules straight. That's where you may struggle here. Okay, so those are your two basic rules. What about dividing signed numbers? What about dividing signed numbers? Well, you know this, that division's the opposite of multiplication, right? So therefore, the sign rules, it's just an inverse property. The sign rules are going to come out very similar. So if I had a positive 12, and I divided it by, say, a -4. Well, how did I get a positive 12 in the first place? I must have had the same signs, right? So if I had the same signs to begin with, then this -4 has to have a matching -3. If I had a -12 being divided by a -4, well, how do I end up with a negative? I would have had to have had different signs to begin with, right? So I have to go with the different sign of +3. If I have a positive 12 and I want to divide it by a +4, how did I get the positive in multiplication? By having the same signs. I need a matching sign, +3. But if I had a -12 divided by the +4, how did I wind up with a negative? Different sign. So I need to go with the different sign from the +4, which is -3. If I lost you, that's okay. Come back to me now. Notice every time the signs matched, you got a positive. Every time the signs differed, you got a negative. The division rule is the exact same as far as signs go. So the same thing you just marked for multiplication is the same thing we're going to have for division. If the signs are the same, class, you get a positive. If the signs are different, you get a negative. So multiplication division isn't automatic. There's no choice having to be made. It's just you know what the sign's going to be. Look at page 110. Look at page 110, and you see there for multiplication division, it's the same rules. Right? You see that little box there on page 110? Same sign positive, different signs negative. You see the breakdown there. 6 divided by 3 is 2. 6 times a third is 2. -6 divided by -3 is 2. -6 times a third is 2. And again, you can think of multiplication by the reciprocal, right? We talked about dividing fractions, so that's the same as multiplying by the reciprocal. That's another reason why division and multiplication are going to have the same rules. Because in a sense, division is multiplication. Look at the example problems. They're on page 110. Look at the first one. -8 times -2. Are the signs the same or different, class?
Same.
And for multiplication division, if the signs are the same, it's automatically a positive. And then 8 times 2, of course, is 16. Look at the second one. -21 divided by 3. For multiplication division, if the signs are different, we automatically get a negative. And then 21 divided by 3 is 7, so -7. Look at the next one. Signs are different. That means we're going to get a negative. And then 6 times 3 is 18. See how easy that is? Questions at all on that? Seems easier than multiplication or addition?
No.
No, doesn't seem easier. Anyway, look over the next page. I want you to do 1 through 23, the odd. Page 111. 1 to 23, the odd. And if signs match, put a positive. If signs don't match, put a negative. And of course, do the multiplication division too. Aiden's finished. Evan's finished. Glenn is finished. Jaden's finished. Hayden says Jaden's not finished. Hayden doubts. Hayden says Jaden doesn't even know what page we're on. We're on page 111. Jaden says Hayden is rude. I'm not sure how we're having this conversation. Okay, Hayden didn't actually say you don't know what page you're on. Rocky's finished. Kyla's finished. Lexi's finished. Evie's finished. Aubrey's finished. Michael's finished. We named no names. Actually, I just named a whole bunch of names, just not one.
Well, dang.
All right, let's take a look at these together for sake of time. Number one, what do we get for our answer, Glenn? Huh? Negative 20. I thought you said negative 2. Negative 20 is correct. Number 3, Evie. Negative 40. Number 5, Aubrey. Negative 15. Number 7, Lexi. 0. Not positive or negative because 0 is just a big nothing. Number 9, what did you get? Hayden.
24.
Positive 24 or just 24. Number 11, Michael.
Positive 16.
Positive 16 or just 16. Number 13, Danielle. Negative 3. Number 15, Glenn. Oh, Evie. Negative 7. 63 divided by 9 equals 7. Number 17, back to Glenn for redemption. Negative 12. Number 19, Aubrey.
3.
Positive 3 or just 3. Number 21, Lexi.
4 or positive 4.
4 or positive 4. Way to give me both answers to show off. Number 23, Michael.
Negative 9.
Negative 9. Anyone get all the 12 of those right? I'm going to go 12 for 12. All right, 11 for 12. 10 out of 12? You got any right? Okay. Questions on any of those? Questions on any of the odd problems? All right, I want you to do numbers 2 to 24, the even. All right, let's take a look at the evens now. Number 2, we'll start with Hayden. 27 or positive 27. Number 4, Danielle.
8.
Or positive 8. Number 6, Evie. 5 or negative 5. Number 8, Glenn. Negative 12. Number 10, Michael.
Negative 22.
Negative 22. Number 12, Aubrey.
96.
Positive 96. Number 14, Lexi.
Negative 5.
Negative 5. Number 16, Hayden. Positive 7. Number 18, Danielle.
5.
Positive 5. Number 20, Glenn.
Negative 6.
Negative 6. Number 22, Evie.
Negative 11.
Negative 11. Number 24, Aubrey.
8.
Positive 8. How many went 12 for 12 this time? Any questions on multiplying, dividing, signed numbers? Seems pretty easy. All right, now, just as with addition, subtraction, or adding numbers, you can have multiple addends. When it comes to multiplication, you can have multiple factors being multiplied. Look at the bottom of page 110. There's a little blue shaded box that gives you a negative 2, or excuse me, a 2 times a negative 6 times a negative 3 times a 2 times a negative 1. And you could work your way through progressively. That's what they show initially. 2 times negative 6, you notice, gives negative 12. Then they multiply that negative 12 times the negative 3 to get 36. Then they multiply the 36 times the 2 to get 72. Then they multiply the 72 times the negative 1 to get negative 72. But there's a much easier way to do this. Every time you multiply by a positive, nothing changes. Because if you already had a positive, times a positive stays positive. If you have a negative times a positive, the signs are different, you get a negative. But every time you multiply by a negative, the sign switches. For instance, if you had a positive times negative, that's different, sign's negative. But if you had a negative times negative, same sign's positive. So the negatives are what switch the signs. That's all we really care about. And it's going to switch every time you have one. So the first negative is going to switch you to a negative. The second one switches you back to a positive. Third one, back to a negative. Fourth one, back to a positive. Fifth one, so on and so forth. So you see the rule there in bold, an odd number of negatives gives you a negative. And an even number of negatives gives you a positive. I want you to mark that bold statement next to the blue box. So that instead of keeping track of positive and negative the whole time, we ain't going to mess with that. We're just going to count up how many negatives there are. Again, we don't care about positives. We're going to count up the number of negatives, figure is that even or odd. We're going to stick that sign on the answer when we're done. So we ain't got to keep track of it because mathematicians are lazy. So I look at the original problem and I'm like, let's see, that's 1, 2, 3 negatives, class. 3 is an odd number, so I know I'm going to get a negative. Then I do the multiplication, but I go out of order here, right? I'm like, all right, I got the 2 times the 6, class, and I got the 3 times 2, 12 times 6, and I forget about the 1 because we need to multiply by 1. Make sense? And then we can be a lot faster. So if there is a series of factors, if there are multiple factors, then in that case, we don't need to worry about the constant back and forth and stuff like that. Look at the yellow box on the next page, page 111. How many negatives do we see, class?
2.
On the yellow box?
4.
I see 4 negatives. 1, 2, 3, 4. That's an even number, right? So my answer is going to be positive. And then let's see here. I got, 8 times 3.
44.
5 times 2.
10.
24 times 10.
240.
240, because you stick a 0 on the end of the 24. Boom, I'm done. Just like that. Instead of the one step at a time nonsense, because ain't nobody got time for that. Does that make sense? There's another application. What if I had a negative 2 times a negative 2 times a negative 2 times a negative 2? There's a much faster way to write that.
2 to the 4th.
Negative 2 to the 4th power, right? So what about if we're showing multiplication of repeated factors using, say, an exponent? Well, we understand that this means this, right? So when I see the negative 2 to the 4th power, that tells me there would be how many negatives if I wrote it out? 4, as we can literally see here. So I know my answer is going to become a positive. And then I just got to figure what 2 times 2 times 2 times 2 is.
16.
16. Does that make sense? So you see this in bold. A negative number raised to an odd power results in a negative answer. A negative number raised to an even power results in a positive answer. You see that bold at the top of the page? Why? Because the exponent tells you how many negatives you're going to have. What about a positive? Remember, positive doesn't change anything. So a positive to some power is always just going to be positive, right? Because nothing gets changed, because it's only negatives that change things. So you're only worried about the negatives. But I want you to notice something here. Look in the blue shaded box. They point this out that negative 2 squared means negative 2 times negative 2, which would be positive 4, because we have 2 or an even number of negatives. But negative 2, when you cube it, becomes
Negative 6.
Negative
8.
Negative 8. We have an odd number of negatives, so my answer is going to be negative, and of course 2 cubed is 8. But that is not the same thing as negative 2 squared. Remember, if I wrote this expression, 3ab cubed c squared d to the 4th, what's being raised to the 4th power, class?
The D.
Only the d. Only the thing that comes right before it. What's being raised to the 2nd power? Only the c. What's being cubed?
B.
Only the b. What's the power of the a?
1.
A 1, technically, right? Because there's a single a. What's the power of the 3?
Just
A 1. It's 3 to the 1st. That's its power. It's 3 to the 1st power. It's just a single 3. So here, what is being squared? Just the 2. The negative is in front of the 2. It's not grouped with the 2. Do we see the difference between negative 2 squared and negative 2 squared? See that? So when I square a 2, I get, class, 4. But the negative is just floating in front. Negative 4. Does that make sense? So if the negative is grouped, that means we have that many negatives. If the negative is in front, there's just the one negative that's just sitting out there doing nothing. Right? You see that as well, negative 2 cubed. What's being cubed?
The 2.
Just the 2. 2 cubed is 8. And of course I still have this negative that's just sitting there. Does that make sense? Okay, so I wanted to point that out as well. One more thing that you should already know really well, but the next blue shaded box, if there's a 0 in a series of factors, the answer is always 0. Again, let's assume there's no addition or subtraction somehow messed in there, but it's all just straight factors and you see a 0, go fast and just get the 0. Questions on that stuff? So anyone need to see more examples before you try it, or you feel like you got it? More examples? Which one? Series of factors, powers?
The one especially with like the similar to that.
So with the series of factors, or like with written with exponents?
Like with series of factors and like how you would like no.
All right, first thing we're going to do, class, we're just going to figure out what our sign is. And figure out our sign by counting up the negatives. Danielle, how many negatives? 3. Is that even or odd? So my answer is going to be a?
Odd. Even. Odd. Number.
All right, class, if we have an even number of negatives, the answer is positive. If we have an odd number of negatives, the answer is negative.
Yeah.
Here you said we have 3, which is an odd number, so my answer is going to be negative something, right? And then we just kind of go in order here. Let's see, I like the 5 times 2 class, 10. And let's see, 3 times 4 times 2, 24 times 10. But we've already figured out the sign ahead of time. Does that make sense with series of factors? And then again, if I had like a negative 3 cubed, well, how many negatives technically do I have, class? 3. That's still an odd number, so my answer is going to be negative. And then we worry about 3 cubed. 3 times 3 times 3 is 27. Does that make sense now? All right. Good. Any other questions? All right, let's go and tackle some of these then. I want you to do 25 to 35, the odd. 25 to 35, the odd. Yes, sir. Question?
What's 35?
Ah.
Yeah.
Yeah. Well, tell you what, we'll get to that in just a second. If we're going to Let's make sure we got the other ones done. We'll talk about 35. And that's why we do evens then odds, to give us a chance to, okay, if we're not sure about something, explain it. Oh, okay, I got it now. And then we'll practice again and confirm we got it. So, yeah, think it through, see if you can figure it out.
Maybe.
Let's take a look at these. Number 25, what did you get for your answer, Evie? Negative 30. My answer is negative because there's only one negative. That's odd. Number 27, what do we get for our answer, Glenn? Oh, Glenn. Aubrey?
-1.
Negative 1. The answer is negative because I have 3 negatives.
That's what he said.
I thought I said 3.
No, it's a negative. He said negative.
You got to speak up. Speak up so I can hear you, please. Let's try this again. Glenn, number 27? Ooh.
-1.
You still sound unintelligible. Come on. You gotta be able to speak clearly if you want a good job one day. Try this again.
-1.
Hey, it's kind of you could do it. All right, number 29. Let's try this from the top. So, number 29, Glenn.
-36.
I see, I understood every bit of that. -36 is correct. We have 3 negatives. That is going to give us an odd number of negatives, -36. Great job. See there? Number 31, we have -2 to the 4th. Now, we just did this one technically, so it's kind of cheating, but whatever. Lexi?
16.
+16. Positive because we have an even number of negatives that are there. Number 33, what did we get? Oh, we just did that one too, didn't we? Hayden?
-47.
It took all the fun ones. And then number 35, we've got a -4 squared. What are we squaring, class?
The -4.
-4. Now some people are like, ooh, I know negative times negative is positive, but wait, you're right. There's a multiplication right here, and there's an exponent here. Which one happens first in order of operations? You cannot multiply the negatives yet. You have to take care of the exponent first. So ignore the multiplication. -4, when you square it, Michael, gives you
16.
+16, because you have an even number of negatives. So we get a +16. Now, I've got this negative, or technically you could say -1 floating out here. And a negative times a positive, class, gives you -16. How many had that? Good, you figured it out. Good. Questions for those who didn't? Does it make sense now? Go back and do the odds, or the evens now. Numbers 26 to 36. 26 to 36, the evens. Good, most of you figured that out. That's good. Are those lava lamps?
They are lava lamps. I got them from the airport.
All right, let's go and take a look at these as well. Number 26. Danielle, what did you get?
-135.
Good, there's one single negative, that's an odd number, so -135. Number 28, Michael.
-96.
Was there ever a more purposeless 1 at the end? -96 is correct. There are 3 negatives for a total which is odd, so -96. Number 30, Hayden. 0. I like those. I like easy ones. Number 32, we're raising a 2 to the 4th, and then whatever we get gets multiplied technically by a -1. So what do we get for our answer, Aubrey? -16 is correct. How about number 34, when we square the -3, Lexi?
9.
+9, because we have 2 negatives there. And then number 36, Glenn, what did you get for your answer there? I'm sorry? Evie? Who? +12. Well, not 4 plus 4 plus 4. 4 times 4 times 4. So Glenn was close. We've got here the -4 cubed. And Glenn, if you were to cube the -4, that would be -64. 4 times 4 times 4 is 64, and you've got 3 negatives right here, which is negative. But we still have this -1 technically that has to be multiplied by the -64, so should have given us positive 64. Does that make sense now? All right, questions on these even numbered problems? Yes, ma'am.
30 or 32.
On number 30, well, if 0 is a factor, it's automatically 0.
Yeah.
And the number 32, we've got negative, or -1, times 2 to the 4th. So we raise 2 to the 4th power, which is straightforward, it's just 16, right? There's no negatives involved here. And then we multiply that by the -1 to get the -16. Does that make sense? All right, any other questions on these? Go to the bottom section here, and you get to fill in the missing signed number for 37 to 48.
Oh.
Yep. Several people finished. All right, pencils down. Well, let's take a look at our answers. Number 37, what goes in the blank? Danielle?
4.
4 in the blank. Number 38, Glenn? -9, because to get a negative answer, we need opposite signs. Number 39, Aubrey?
11.
11, we need to have a positive there to contrast the signs to get the negative answer. Number 40, Hayden? -6 to match the other -6, so we end up with a positive. Number 41, Michael? -4 to produce the negative sign. Number 42, Evie?
3.
+3. Number 43, Lexi?
24.
+24. Number 44, Hayden?
-2.
-2. Number 45, Glenn? 2 or +2. Number 46, Danielle?
-132.
-132. Number 47, Michael?
-7.
-7. And number 48, Evie? Aubrey? -8. -8 divided by the 4 gives -2. Now, if it were the other way around, 4 divided by what gives -2, that would have been a -2. But what divided by the 4 should have been a -8. Anyone go? Let's see, there's 12 of them in there. Anyone 12 for 12? But 11 for 12? All right, any questions on the one-on-ones we missed? All right, turn the page. And go ahead and read problem 49 for us, if you would. Michael?
Michael pays $20 per month cell phone bill from a checking account. Express the yearly effect on his cell phone bill has on his checking account as a negative number.
At your seats. Take just a moment to work that. Every month he pays $20 from his checking account.
This is regular year or not a leap year, right?
Well, this is every month,
Oh.
not every day. So in the course of a year, what is the effect on the checking account balance thanks to his cell phone bill? That is a very low cell phone bill. First of all, how would we show $20 going out of the account balance, class?
Like multiplication.
Negative 20, right? Negative 20 means the $20 is coming out of the account. The account is decreasing. But then every month he pays that much, so in the course of a year, we'd have to do what, class?
Multiply.
Multiply by 12. Negative 20 times 12 gives us what effect on the account balance? Negative $240. Negative $240. How many had that for number 49? Questions? All right, number 50. Danielle, read that.
When you put it on like the thing, does the negative go before the dollar sign?
Ah, good question. Yeah, we put the negative before the $240. Though, those of you who've had computer applications, if you're in the accounting mode, you know the dollar sign always goes at the beginning, so then they would put the negative 240 in here, of course, with your 2 decimal places. Also, quick review from Excel, it might also put it in parentheses instead of the negative. So any of these, and by the way, most banking accounts, if you set parentheses, that implies the negative. They won't put a negative sign. They'll put parentheses around it. Or sometimes turn it red, or both. So anyway, some stuff from Excel for those who've already had that class. All right, number 50, read it for us, Danielle.
The temperature outside is changing at a rate of 4.5 degrees Fahrenheit per hour. If the temperature is currently 45 degrees Fahrenheit, what will the temperature be after 4 hours?
All right, well, if it says it's changing at a rate of 4.5 degrees per hour, class, at negative 4.5, it means the temperature is going down, right? Because negative implies it's going down, it's getting lower. At your seats, you're number 50. And don't try to cheat and read the thermometer, it's not correct. They just found a random clip art of a thermometer reading 0 Celsius and 32 degrees Fahrenheit. That is not our answer. If it drops for 4 hours at a rate of negative 4.5 degrees Fahrenheit, what should we probably do first, Aubrey? What did you do?
I don't know.
You were working back there. You're doing something. Michael?
Multiply.
I would start by multiplying the negative 4.5 by 4. How many did that? You multiply the negative 4.5 by the 4 to see how much the total drop was going to be. What was that total drop?
18.
Yeah, negative 18 is the total drop. So if we take our 45 degrees we started at, and we add to that a negative 18 degree Fahrenheit drop, that should give us what resulting temperature, class?
Negative 32.
Oh, careful.
53.
Oh my.
63.
We're adding a negative 18.
27.
27 degrees Fahrenheit. Subtract each side of the greater absolute
Is it
value.
negative?
Because it's dropping. The temperature's going down, so it's a negative temperature.
Oh.
Now, granted, adding a negative is the same thing as subtracting a positive, right? So if you just done 18 and subtracted 18, you get the same answer. Or you could add the negative 18, which still gives you 27 degrees Fahrenheit. At your seats, do 51 to 53. At your seats, do 51 to 53. I will say intuitively, I think it's easier just to be like, yeah, 4.5 times 4, subtract that from 45. It's easier than adding the negative, though technically it's the same thing. So. (51 to 53). right, Aubrey. Number 51, how should I rewrite that so that there's no parentheses?
Negative 9, negative 6, negative 11, negative 2.
Well, but it says minus negative 2. We don't do that here.
Oh. Make it a positive 2 and positive 8.
There we go, good. And then I want to get all my negatives together and all my positives together. Let's start with the positives because that's easier.
10,
Positive 10. And when I get my negatives together, I'm going to start with these two.
20, 26.
So negative 26, right? And then we have one subtraction to do, and our answer is
Negative 16.
-16. How many have that answer? -16. Again, could you go in order? Sure. I just think it's easier this way. Number 52, how should I write that so there's no parentheses? Lexi.
Negative 6 plus 7.
Or positive 7.
Or positive 7, positive 2, and then negative 3, positive 8.
Good. Once again, let's get all of our positives together. I'm going to start with these two positives, though.
16. Oh, 10.
10, and then 7 more.
17.
17. And that's the reason why, because it just makes the addition that much easier. We'll get our two negatives together.
Oh, 9.
Negative 9. And then we'll do one singular subtraction to get
I got 9, 8, 8.
positive 8. Should have been our answer. How many positive 8 for number 52? The number 53, we need to follow order of operations. Order of operations says we start with the parentheses class to just get 2, or positive 2, but I can just write 2. And then that's up against another 2 with a negative 12 at the end. Well, since the 2 and 2 are up against each other in parentheses class, we get 4 when we multiply. You could say positive 4 if you wanted to. And positive 4, negative 12 class just gives us negative 8 when we subtract and keep the sign of the greater absolute value. Questions on those? And then we go 3 for 3 on those. Good, a few of you did. Excellent. Any questions? All right, homework for this evening is to do page 112, numbers 1 through 27. Page 112, numbers 1 through 27. On the homework section. Well, I guess that's the only 1 through 27 on it. Page 112, homework numbers 1 through 27. We'll take a look at that tomorrow as we wrap up this section, or these sections, on signed numbers. Have a wonderful rest of your day, and when the bell rings, you will be dismissed.